Thank you very much, Mr. Chairman. It's a pleasure to be here. My name's Alan Gooding. I am based in the UK. I work for a company called Smarter Grid Solutions, and we provide control technology to a number of utilities around the world to help them integrate renewables into their grid. And we partner here in India with NZN Global Solutions. What I'm going to try and do is take you through some projects that I think are very interesting from my experiences of going around the world. I figured, given the American and German influence of the conference, that the sorts of things that would be talked about. So I'm still going to talk about those markets, but I'm going to talk about some very specific things that I think are a little bit different, smaller projects that I think show signs of the way forward and how specifically they relate to India. I've been coming over here now for the last 9 months. I've pretty much spent a week of every month over here working with regulators, politicians, DISCOMs, the SLDCs, and many of the stakeholders. So I think I've got a reasonable knowledge of the local market. And I think one point I would like to echo as we start, Dr. Ackerman yesterday talked about how every power system is unique. And actually, it's a point I would agree with. And a lot of the uniqueness about the power systems comes from the history. It comes from the geography. It comes from previous investments. It just comes from the way that culture has developed. So I'm going to try to find ways to help bring some of these things that have gone on in other places to the relevance of the very specific and unique situation here. I'm not going to spend any time at all talking about the context of the Indian market. Everybody knows it, but there's the thing that's really key is to understand the things that are different from lots of other places. And that's just the extent of the geography, the extent of the population, the rate of demand growth, and the regionalisation of renewables specifically. And every state, because it's a federal structure, has its own specific challenges. And that's more akin to the structure that you have in a pan-European structure or in North America. And Dr. Ackerman did a great job of talking yesterday about some of the challenges. I just wanted to bring a few of them to bear. Some of them are technical, some of them are commercial, and some of them are regulatory. On this technical side, we see system stability as one of the key challenges here in India, particularly now that we are moving from a situation of energy surplus, but with limited margin and limited reserve capacity. That means that it's not like the situation in Europe or North America where there is abundant reserve and flexible capacity and abundance of generation. Just point out some of the differences, you already know them. One of the other common challenges that we're now starting to see much more of is voltage stability, not just frequency stability. Now, voltage stability is much more localized, but in places like the UK, I think are good examples where the challenge of inverter-controlled renewables pulls down the amount of reactive power that's available within the system. And the system operator in the UK has identified this as one of the most severe risks to blackout, and such that they're starting to introduce new things to the market in order to be able to deal with it. And then the commercial issues range from being able to maintain generation fleet viably. They come from maintaining capacity on the system so that peak can be met. And they also come from a growing understanding of the value for reserve and flexibility in the market to operate the system. And from a regulatory standpoint, that means that the way that the industry is funded, the way that the incentives are structured, and the investments that have to be made, whether it's by DISCOMs or SLDCs or whoever else, has to change. So I'm going to quickly go to round 4 projects that I think are particularly interesting. I'm going to start in California, and I'm going to talk a little bit about how technology is the major driver for change there, whilst In New York, the driver is much more market-based in the desire to create different sorts of revenue streams for the participants within the market. And then I'm going to emphasize the sort of more engineering approach that's been taken within Germany, and then specifically some of the technical challenges in the UK, mainly because it's an island system, which the minute you start to have higher penetrations of renewable, the problems are much more acute than in a big, stable system. So, in California, so what's different about California is that most of the renewable energy is actually connected at distribution voltages rather than at transmission. That doesn't mean it's all domestic PV or rooftop PV. Actually, a lot of it's industrial and commercial customers. And the motivation is purely to reduce demand charges. It's not because they want to save the planet, it's because they want to save money. And it's the same driver that's encouraging these sorts of customers to deploy energy storage. So Southern California Edison, I've seen a massive ramp up on the amount of resources that want to connect to their network. And their challenge is then how to facilitate all of these projects coming at them. And they're estimating that they'll have 1 million domestic customers who'll be prosumers, who'll be generating electricity onto the network. And they'll have thousands of other people who are aggregating resources, whether it's electric vehicles, different types of demand for them to be able to interact with. And so they're taking this view that they're going to be the sort of critical point in bringing those things together, making sure that the physical network underneath is maintained and remains reliable, but providing access to the different markets, either for network services, ancillary services, or the wholesale market. And so their driver has really been to deploy an architecture that lets them scale up to think about how they facilitate that from a network stability and reliability point of view. And what the technology can then enable from markets that's then driving what the markets are being able to facilitate underneath. So it's a technology-driven change that's going on in that market. In New York is slightly different, and I'm going to talk specifically about energy storage here as an example, because it's been mentioned a few times. And actually, it was on the back of Hurricane Sandy a number of years ago that New York instigated this program called REV, Reforming the Energy Vision. And it was really about how do the utilities change their business models and how they can make income in order to facilitate the change that customers and IPPs, etc., want to have in the market. So how do they create flexibility? And one of the sort of big REV demonstration projects is actually on front of meter storage. So this is not at the domestic level or the customer who wants to simply save in demand charges. These are grid-facing Con Edison type resources. And the challenge there is energy storage, when it's for a single application. We've talked about here about balancing the system as a single application for bulk energy storage. When it's a single application, energy storage is not commercially viable. And that includes within a city where the cost of building a substation is $1 billion. Okay, so just have reality on what energy storage can do, at what scale and at what price. But, and here's the but, actually, the view there is that if you can stack different revenue streams, if you can allow that asset to participate for a number of different value streams, then it can be made commercially viable. And that's precisely what this project is doing, is providing capacity for Con Edison to improve reliability. It's providing capacity to Con Edison for peak load management, but the rest of the time it's participating in the wholesale and balancing services markets operated by the New York ISO. So, California technology-driven, New York market-driven. Germany, I would describe and characterize as being quite engineering-driven. So, We've heard a lot of the case studies about how at a system level, Germany has adopted renewables into the system, but it's not been without some fairly profound change. You just need to look at the market capitalization of major European utilities over the last 10 years. Little known fact is that they lost more money in that period than the banks lost in the crash in 2008. That's a lot of value destroyed by the change that renewables has brought to the system. But those utilities are changing. The consequence on customer bills, the pressure on those utilities is fundamentally changing now the business model in which they're operating. They're thinking much more about being services companies, providing flexibility into the system and using their asset base much more flexibly to support the system. Now, Germany is very well interconnected in Europe. It can have high penetrations of renewables, with relatively limited problems. They have the hydro in Scandinavia, they have the Alps, they have connections through the Mediterranean. So actually, as they have excesses in renewable energy, it's relatively easy for them to export it to different parts of Europe. Still, from a system operation point of view, despite, and not just because of economic reasons, but purely because of technical reasons on stability and the ability to evacuate through the transmission infrastructure they do implement RE curtailment on a fairly wide-scale state. They have gigawatts under management. And most of this is actually spread out through the distribution level. And that is and remains a very cost-effective and economic way for them to operate the system, the most economic way. Now, because of what's been seen with that, Germany is actually now starting to adopt that through the sub-transmission and distribution networks to allow technical constraints on those networks also to be managed. It's been dubbed or been called the 3% rule. And they've estimated that if they can curtail RE up to 3% on those networks, they can double the hosting capacity of their network, saving billions in euros, even though that curtailment is compensated. And we see exactly these sorts of applications in North America, in UK, in Japan, and lots of other markets where actually the ability to build and finance the infrastructure to maintain a passive system is no longer viable. And I would suggest as India moves forward that RE curtailment doesn't just get seen as a bad thing in the system, but becomes something that's recognised as being the economically rational thing to do. In the UK, as I said, it's all been driven by the two big issues of frequency stability and voltage stability. In voltage stability, the solution is typically to build assets, capacitor banks and things and the like. But actually, a lot of these RE projects are able to provide flexibility into the system. So new market services have been introduced to procure reactive power support from IPPs. And that, as you can see from the graphs, results in fairly massive capital expenditure savings. And so just making those things relevant to India, the foundations are in place here, but some of the structures aren't necessarily in place. One of the good examples, we've been talking to various discoms, is actually taking that example of reactive power support. For a very small area of network, rural and urban and discom area, the ability to manage reactive power can significantly reduce the technical losses in the distribution network. And this example here shows significant both CapEx and OpEx examples. And this is from real data. And equally, some of our experience in being able to operate renewables in this more flexible way allows us to avoid curtailment. So the graph here is a real graph from a system in the UK where renewable curtailment would have been operated traditionally in these blocks. the orange line, and by allowing the system to run as much as possible, allowing renewables to participate as much as possible, we were able to increase the RE output to the blue line. And the graph just shows you the amount that we were able to change it. So from my point of view, and just to summarise in the interest of time, every technical solution requires a commercial solution. All of these have a market or something that's underpinning them, an ability to procure a service. RE can provide opportunities and not just problems. The inverters and actually how flexible the machines are to ramp up and ramp down provides opportunities to consider them actually as part of reserve and not just be something that spills electricity onto the network just when the resource is there. And I would encourage the concept that RE curtailment in that regard is not necessarily a bad thing, but it's actually a very economically rational thing, both to help balance the system, but also to help mitigate the cost of the infrastructure upgrades. And to make this transition and to make some of these changes requires vision, hard work, commitment. And it's also going to require more than us just talking about it here, but actually building some of these things out and showing the industry how it can actually, how some of these practices can be implemented here in the very specific and unique context of the Indian power system. I'll leave it at that. You get the materials and I'll happily take any questions now. Thank you very much for your attention.